Well, good morning. I'm honored to be again part of the U-Bar-U Star Party, although this format is a little bit different because of current events. Some of you in the past have seen me live at U-Bar-U, and for those of you who have not seen me before, let me introduce myself. I'm Robert Reeves. I'm an amateur astronomer for the past 60 years. I'm fairly well known for my lunar work, and I'll show you some of that here briefly. But tonight or today, I'm going to branch out into two different directions. The title slide shows birth, death, resurrection, and immortality in the Milky Way. Well, this is a portion of the presentation that is based on my fascination with what I photograph through my telescope. I'm a fairly well-known celestial photographer, and what I see in my images fascinates me in the sense that in some images there's areas where stars are being born. In other images there's areas where stars have died, and there's evidence in other images where elements created by the death of a star have resurrected into new stars. And this process is extremely important because we wouldn't be here if that didn't happen. Our own sun, the Earth, the whole solar system is made from recycled star stuff. Every element in our body was forged in a star that lived long ago, died, blew up, scattered its elements across the universe, and somehow, through some force of physics, some people would think through some divine intervention, these elements came back together again and created new planets, new stars, and eventually us. So just seeing this process in my own photographs, the evidence of this process in my own photographs is, you know, it's kind of staggers me. I've been an amateur scientist for years, and sometimes the reason for that happening is a bit of a mystery to me. So it kind of, in a sense, mixes a little bit of religion into this science. It's just hard to believe that pure physics drives this. Something has to be scooting all this stuff around in the universe, because the universe is so vast, so wide, so far, with so much space in between. How did all of these elements find each other and come back together again after they were scattered across the universe by a massive star explosion? So, before we go too far, the other thing I wanted to show today, the previous presenter, Amanda Bayless, she showed some very fine images taken by the Hubble Space Telescope. These are very beautiful images of the universe, but Hubble's images are kind of an anomaly. They're stunning, they're beautiful, they're great PR for NASA. They connect us with the beauty of the universe. But most astronomical data taken through a telescope is in the form of a digital signal that is being reduced to numbers on a graph or a chart. Pretty pictures that show us the beauty of the universe is not the goal of professional astronomy. The people who create the lovely images that we see in books, magazines, illustrations, science articles, those are primarily created by amateur astronomers. And I like to think that us amateur astronomers, particularly astrophotographers, people who photograph the sky, are the link between the public understanding of science and the raw science of astronomy itself, because the public isn't going to get a thing out of a graph showing a bunch of numbers. Scientists will realize, oh yes, that shows the orbit of a planet around another star, an amazing thing, another world like ours orbiting another star. But from the numbers, you don't see that. Only a scientist will see that. We have to rely on the images produced by astrophotographers to make our visual connection with the universe. So as I go through my presentation, I'll be, talking about birth, death, resurrection of stars, but I want you to look at the pictures themselves and realize the amazing things that are in the sky, the nebula, the star clusters, the clouds of the Milky Way. Our visual representations of those primarily come from amateur astronomers. So let me press on here and introduce myself. That's me and my current telescope, my Big Celestron 14 that I got it last year. The young lady is Pranavera Hysini, a very well-known, internationally known astronomer from Kosovo. A number of years ago, I invited her to the United States to speak at a conference. And since then, she has gone on to return to the United States and pursue a doctorate in planetary science at the University of California. So I'm very proud to have brought her over to the United States initially and put her on that path. So my background in astronomy, like I said, I'm an amateur astronomer. I don't have a degree in astronomy, but I have 60 years of experience. And in that respect, I'm the only person to have ever written 3 separate books about celestial photography. In 2000, I wrote, or was published, I wrote it before then, but it was published in 2000, Introduction to Digital excuse me, I got that wrong order. The one in the center, Wide Field Astrophotography, came out in 2000. Well reviewed, but it was based on film astrophotography. And anybody who knows the history of photography knows that shortly after 2000, virtually everything went digital. So in 2005, I wrote Introduction to Digital Astrophotography and followed that a year later with the book on the right, Introduction to Webcam Astrophotography, which led to the birth of the planetary camera industry, where now amateur astronomers are able to take pictures of the moon and planets that are equal or better to those previously taken by professional astronomers from Earth. So my main area of expertise is the moon. I'm well known in that, but today we're going to be exploring things beyond the solar system, the beauties of objects within the Milky Way. So continuing on a little bit more about my background, my pictures have been published on the covers of books, have appeared in magazine articles, some of which I wrote myself. My lunar imaging techniques allow me to take better photographs of the moon than the professionals could back during the Apollo era, before we put spacecraft in orbit around the moon. So throughout all of this, I like to say I have no special talent, no degree or training in it. I'm only passionately curious, and that leads my explorations of the universe. And in that effect, I'm no more well equipped than you are. Your curiosity will lead you wherever you want to go. So, getting into the meat of things, we know there's millions of galaxies out there. One of them is our cosmic home, the Milky Way. And if you keep hearing a cat meow, yes, there's a cat in my lap at the moment. This is Rusty. She's a little miffed because my laptop is on my desk to do this recording session, and that's her place. She likes to lay on the desk while I'm working at the computer. So she's kind of making her presence known. But anyway, millions of galaxies. We've seen pictures from the Hubble Space Telescope showing no matter where we look, in any direction, there's just thousands and thousands of galaxies as far as we can see. Our own Milky Way is just one of them, a speck afloat in this sea of galaxies. And we believe that it looks pretty much like this spiral galaxy, M81, up in Ursa Major. Also very similar to M33, the Triangulum galaxy in the constellation of Triangulum, the Pinwheel galaxy in the constellation of Triangulum. But the one that most best fits the appearance of the Milky Way, we believe. I mean, obviously we can't see the Milky Way from outside because we're in it and the distances are staggering. We will never, probably never see our own galaxy from outside. We believe it looks like the Andromeda Galaxy, M31, this beautiful pinwheel spiral whirlpool looking thing. It's just 200, 300 million stars all in this swirling mass, and even closer up to it. So if this was our Milky Way and we're looking at it from afar, our own sun lies up here about 2/3 the way out from the center. And a good thing too, because if we were closer to the center, the dark, densely populated core of our galaxy, the radiation levels would be so high that life as we know it would be impossible. So we're kind of out here in a real nice, safe zone where we can look out at the night sky and see all these marvelous things. But you have to realize that every star we see in the sky, every nebula, every star cluster, is only in our immediate little tiny corner of the Milky Way. The distances are so vast that we cannot see stars on the other side of the Milky Way. They're at such great distances, they just all blend into this homogeneous glow that we see as the Milky Way itself. We can't resolve individual stars. We can't see the nebula and star clusters on the far side because they're just so far away. So bear in mind that everything we see in the sky is just in our own little corner of the Milky Way. So how do we see our own galaxy? From within, looking from the inside out. And in that respect, we see it as this milky, cloudy band across the sky. And this particular shot, 180-degree panorama I took last year at McDonald Observatory, just out in the field to the north of the visitor center. Now, this is an area publicly accessible to everybody. It's just off the public highway. They discourage you from, whoops, sorry about that. They discourage you from driving up to the observatories, but nothing stops you. It's a public road. Hello, cat. Nonetheless, this cloud of the Milky Way rising, it's just awe-inspiring when you see it out in its natural element under absolute dark skies. There are 2 generations of people who have lived in cities all their lives and they have no idea what this is. If you have seen the Milky Way recently, well, you've seen something extraordinary. Excuse me, the cat is trying to step on the computer and that's not working. I'm gonna have to put her down. Come on, Rusty. One of the dangers of virtual star parties. Anyway, moving on. Like I said, if you've seen the Milky Way with your eyes, or you go out at the star party tonight and look up to the south, you should see a view very similar to this, the star clouds of the Milky Way in Sagittarius. Scanning with binoculars, you're going to see little puffy cotton ball looking things, nebula and star clusters. And we're going to be examining these and seeing the significance of what these things are. The Milky Way is just in itself a visual stunning spectacle if you get under dark skies. And then just a simple pair of binoculars prowling around like this puffy here, the Lagoon Nebula, or the star cluster M25, or the Eagle Nebula, or the Swan Nebula. These are visible to the naked eye and easily seen in binoculars. And I hope you'll appreciate them more after we take some looks at them. Here's a view actually from the U Observatory 2 years ago. One thing I like about the Southern Milky Way, notice the silhouette of the prancing dark horse. I call it the Great Galactic Dark Horse. It's a combination of a number of Come on, kitty, down. A combination of a number of dark nebula, dust clouds in the Milky Way that will eventually coalesce into new stars. But by chance, uh, this one down here, which is independently called the Pipe Nebula, combined with a number of others and create the caricature of a prancing dark horse. And a deeper view of it with a camera from a darker sky clearly shows it with the planet Jupiter just coincidentally right at the heart of the horse. But all of these dusky dark clouds embedded in the Milky Way, all of this is material that will eventually become stars. In addition, like the Lagoon Nebula here, this little red glowy spot, we'll look at it here shortly too. That is the source material for new stars. And another view of the Milky Way, this one from El Dorado, Texas, about 200 miles west of here. Extreme wide angle view, looking from the horizon up so high that if you look over your head to see the top of the image, you'd probably fall over backwards. And a final one of the Milky Way as seen from Fort Davis, Texas. Every year we have, well, this year we didn't, obviously. First time because of the COVID crisis, we had to skip it. But every year we gather about 500 people out near Fort Davis for a massive star party. And here we see our grand Milky Way arcing over the observing field at the Texas Star Party. This is a 180-degree panorama. North up here, south here. This road passing in front of it is actually a straight road going from south to north. Just the extreme panorama bends it and makes it look like a curve, but it's actually a straight road paralleling this field, and the Milky Way arcing almost straight overhead. See everything from Cassiopeia in the north, Cygnus, Aquila, down into Sagittarius, Scorpius. The Milky Way is just stunning in its own right. Within it, I've mentioned the Great Galactic Dark Horse. I'm fascinated by that collection of dark nebula. And these pictures, I hope, are illustrating my point about amateur astrophotographers being the link between the public and the reality of the night sky. This is the Scutum star cloud in the constellation of Scutum, one of the dense concentrations of the Milky Way. Just an incredibly dense, bright cloud of stars that you can see with your naked eye. And the Sagittarius star cloud looking toward the center of our galaxy, and an area of stars that are so dense and so compact that if Earth or if our sun and the Earth were there, the radiation levels would prevent life as we know it. And looking at the summer Milky Way, here we see the Lagoon Nebula, the Trifid Nebula, various star clusters. These are the Lagoon and the Trifid will eventually coalesce into a star. This is the source material from which stars are born. The star clusters, like the open cluster up here, the globular cluster down here, those are regions where the stars have born, and they're still coalesced together from the original cloud they were born from. And here we have the Eagle Nebula and the Swan Nebula. We'll look at them close up and examine those structures here in a moment. All of these are binocular objects that I hope you will enjoy tonight in the southern Milky Way if the skies cooperate. And looking up in other areas of the sky, this is in the constellation of Gemini. Massive star cluster M35. Stars have already formed there, they're shining brightly, but other areas, these red areas, they glow brightly from the emission of hydrogen alpha light, reactions within the nebula being stimulated by uh, the radiation of other stars makes it emit this red radiation, and we can see these clouds of gas in the Milky Way, and these will eventually gravitationally collapse, coalesce into new stars. And here we see before and after. We've got the California Nebula up here, this arc of stars that resembles the shape of the state of California. Will, again, someday, hundreds of thousands, millions of years from now, coalesce into a collection of stars. We see these dusky, dark lanes of dust, again, source material for new stars. And then the Pleiades down here, Seven Sisters and Taurus, a very young star cluster, less than 100 million years old, newborns as far as the universe is concerned. The star cluster has already been created out of a cloud of gas. And in fact, you can see it's kind of hazy and dusky. That's leftover gas and dust that has not yet coalesced into stars itself. So this is just a baby, newborns in the universe. Other areas of the sky, these nebula take on almost familiar shapes. They get popular names. We have the North American Nebula here in Cygnus, and this other one we call the Pelican Nebula. Looks like his face right here, and his body, and his little wings, and his feet down here. The one in the middle, I simply call it the Skull Nebula because of the two eyes, creepy looking. And just to show you where we are, this is Deneb up here in the constellation of Cygnus. In Scorpius, the Rho Ophiuchi complex, named after the star right here. Stars and constellations are named by or designated by various Greek letters, and this particular one, Rho Ophiuchi, in the constellation of Ophiuchus. The orange one is Antares in Scorpius, and we see the whole region is covered with clouds of dust and gas. This is a very heavy star formation area. Amazing things are happening here. New stars being born. And constellation Sagittarius, the teapot shape of Sagittarius, the handle over here, the top of the teapot lid, the spout over here, and of course the large Sagittarius star cloud is the steam coming out of the teapot of constellation Sagittarius. This whole region just peppered with dozens of nebula going to be stars, star clusters already formed. Just a marvelous place to explore. So the slow process of star formation, I've been saying that we can look at these things and spot these emission nebula, which are these vast clouds of gas that will become stars. One of the more popular ones is the winter constellation of Orion. Just below the belt of Orion, we have this bright region that is more popularly known because of the Horsehead Nebula. I'm going to try something here and see if there it goes. Now, see the silhouette of a horse head here turned on its side. Dark dust clouds embedded in the foreground of this huge, massive region of gas and dust. The Flame Nebula up here, in the process of coalescing, shrinking down, gravitationally contracting, and becoming a star someday. In the summer sky, the popular Lagoon Nebula and the Trifid Nebula above it, these are in Sagittarius and visible tonight in binoculars. This particular picture taken from my home here in San Antonio with a very special lens that or a filter that lets me cut through light pollution. But it shows this massive star formation area embedded within this cluster, or this cloud of gas, are newborn stars. that are in the process of forming as we speak. And the same with the Eagle Nebula above it. Um, a lot of you are familiar with Hubble Space Telescope images. One of the most stunning ones that initially came out was called the Pillars of Creation, showing regions within the Eagle Nebula where stars were being born and coalesced, and you could see that with your eye here in this amazing Hubble picture. So let's zoom in here, and there they are, the Pillars of Creation. These columns of gas that are being evaporated by the pressure of surrounding starlights and revealing the newborn stars that are being born within that collapsing cloud of gas. The fact that you can see something like this from my own backyard, watching stars in the process of being born, is really quite staggering. In the Swan Nebula, same thing, in the same area, just north of Sagittarius, one of these objects we can see with binoculars. We'll zoom in on it a little bit and see why they call it the Swan. The body of the swan is right here, and the arc up here kind of forms his neck and head. And this bright area of the swan is all you see in a telescope. This vast cloud around it is too dim to see visually. It shows up on photographs, but the swan itself is quite striking in a telescope because that's all you see. Another area, like I said, this is star formation before our very eyes. And of course, everybody knows about the Orion Nebula, that bright object in the center of the sword of Orion hanging below Orion's belt. You can see this with the naked eye, even from the city. And you put a pair of binoculars on it, you see this vast cloud, huge. It fortunately is close to us, so it's big. And within it, Hubble reveals baby stars being born. We can see them. And one thing that I think is kind of cute is this dark cloud here, the profile of a face facing downward. His nose, mouth, lips, forehead. I call that Orion's brother, just a personal name. I don't think it's a popular name. One nebula that I did name, however, and popular names of nebula have no official standing. These nebula are officially designated by the International Astronomical Union with a numerical designation that is very unsexy. So most amateur astronomers create our own names. And if the name sticks and becomes part of the astronomical lexicon, great. Well, fortunately, this one did stick. The people were trying to call this the Eagle Nebula, but this is in the winter sky. There's a very popular Eagle Nebula that we just saw in the summer sky. I thought, no, we can't have two eagles up there. So I named this one the Seagull. It looks like a seagull to me. Soaring wings, wings spread apart, soaring in the sky. It's actually upside down. The head is down. But nonetheless, more regions in the sky where these vast clouds of gas, glowing gas, are slowly coalescing into stars. And the Rosette Nebula, this thing is huge. It is almost 5 times as wide as the full moon is in the sky, yet it's invisible to the eye. The camera easily picks it up, but again, just the huge glowing gas clouds in space, creating stars before our very eyes. And the star cluster at the center of it, stars have already been born out of this region in the middle, and star formation is still going on in the denser portions of this gas cloud. And here's the Pleiades again. I mentioned that the Pleiades have already been born. They're not a star-forming region. They are already formed, but notice all the leftover dust and gas that is populating the region. Eventually, that'll be blown away by the pressure of starlight from the new stars in the Pleiades. But This has gone beyond the star formation stage, and these are stellar infants, newborns, just millions of years old, not billions of years like our own sun. Eventually, a star cluster, after it forms, clears out all the dust. Like I said, the pressure of the starlight will eventually blow that dust further out into the into the Milky Way, where it will eventually recycle and combine and become new stars in another generation. But some of you may recognize the V pattern of the constellation of Taurus. And this is bright Aldebaran. The star cluster is very close to us, so close that instead of looking like a small star cluster, it forms an entire constellation. But again, fairly young stars here that coalesced out of a gas cloud, but have matured to the point where it's blown away the gas cloud, and we no longer see the stellar nursery anymore. But they are standalone, bright young stars now. So these stars are born, they coalesce out of this gaseous material. Magical things happen that cover vast blackboards full of equations, and they turn into stars. Nuclear fusion begins to make the stars shine. Hydrogen gas is fused into helium, makes the star shine. The star gets older and older, runs out of hydrogen fuel. It starts fusing helium into heavier elements. And then those heavier elements in turn fuse into more heavy elements. This process is critical to the continued life of the universe. It all began with hydrogen at the beginning, 13 billion years ago. And yet now we have all the elements on the periodic table of elements, from hydrogen all the way through uranium as natural elements. The periodic table now has a lot of man-made elements on it, but up through uranium, all of these were created in stars that blew up. And here we see the Crab Nebula, M1 in Taurus. This massive explosion happened about 1,000 years ago. It is still expanding at a measurable rate. Within a lifetime of a human, we can see that it has grown. Within this explosion, this is where the elements are that create the current generation of stars and planets that have enough chemistry in them to create life like us. So everything on our Earth, everything in our bodies began in a massive explosion like this. Another big explosion, the expanding bubble from another explosion, is the Dumbbell Nebula, M27, up near Cygnus. Oops, didn't mean to do that. And the Ring Nebula in Lyra, up in the summer Milky Way. Let's enlarge it a little bit. It looks very much like a ring, but it's actually a sphere of expanding gas that is rapidly spreading out from a star that exploded fairly recently, within the past 50,000 years or so. And it's casting all of its elements back out into the universe to be recycled into new stars. The Crescent Nebula up in Cygnus, same thing, the expanding cloud of gas blowing outward from a stellar explosion. The Owl Nebula up in Ursa Major, same thing, expanding cloud of gas from a stellar explosion, reseeding the universe, not reseeding as in going away, reseeding as in planting the universe with the heavy elements necessary to make us. So almost everywhere we look, we see these little clouds of expanding gas. We call them planetary nebula. This one doesn't show up too good. Sorry about that. Let's go to another one. There, the little green thing. That's the expanding cloud of material blowing off of an exploded star that reached the end of its life and blew up and is sending all of its material out to do the job all over again. Oops. And a very beautiful example of this stellar material cast back out into the universe is the Veil Nebula up in Cygnus. And even on a huge or grander scale, this arc of reddish material surrounding the body of the constellation of Orion, another expanding shell of star stuff, expanding back out into the universe to recycle itself. So all this stuff gets cast off from a star that has lived its life, burned up all of its nuclear fuel and can no longer support itself, so it explodes in a nova or a supernova and blasts itself back out into space. And this material somehow finds itself again, coalesces back together again, atom by atom, molecule by molecule, across billions of miles of space, and creates new stars. The double cluster in Perseus, shown here. Most star clusters are not quite as dramatic. These are various examples of some of the lesser dramatic ones up there, but nonetheless important because these stars have to be, I mean, we wouldn't exist if these stars weren't formed, if they didn't coalesce out of the material in the universe that is recycled through these exploding stars. But nonetheless, brings us down to the end of this thing where I say birth, death, resurrection in the universe, and possibly immortality. There is a very curious thing about some stars that have been examined in globular clusters, such as M13 here in the constellation of Hercules. Another one of these objects easily seen in a pair of binoculars. Some of the stars in these globular clusters appear, and I say appear because it's clearly contradictory, to be older than the universe itself. How can a star be older than the universe that it lives in? So it's one of the cosmological mysteries that people ponder. How can a star be older than the universe that it inhabits? So lots of philosophical, scientific, almost religious questions going on here. So other star clusters, these little balls of stars populate the Milky Way and leave us these strange mysteries of what the heck is going on here? Why are we seeing things that are so contradictory? It's very easy to work through the physics of how a hydrogen atom can find another hydrogen atom across millions of miles of space and then gravitationally attract others and build until, wow, you've got a star. Enough gas coalesced into a sphere with enough pressure that nuclear reactions happen and fusion begins and the star shines. And it lives out its life and it runs out of nuclear fuel and blows itself apart, creating heavier elements that recycle into new stars and become us. But it boggles me that the forces that drive this, how across such vast distances, and I can't begin to convey the distance from point A to point B across the between the stars in understandable terms that are relevant. They're just so vast. But how all of these elements have managed to find themselves and combine in order to create what we see in the sky is just mystical to me. There's science behind it, but there's wonder and awe in it as well. And it almost drives a religious feeling when you think about it. The forces at work and the results and the consequences of it. It's all part of the science of astronomy, all part of the mystery, the wonder of it, and part of what keeps us coming back to it. The staggering beauty of the Milky Way, the endless possibilities of what could be happening out there. Obviously, amongst all these millions of stars, we can't be the only people sitting here pondering, are we the only intelligent life in the universe? No, I'm quite convinced there's quite a few other eyes out there looking back in our direction, wondering if they are the only ones in the universe. The pure chemistry and science and physics of how all of this works uh, has to have created other intelligent beings in addition to us. So if the sky is clear tonight and you're at the U-Bar-U, I hope you go out and enjoy the Milky Way. It's a real treat to see it. And look up some of these objects I've been talking about. Like I said, many of them are visible in simple binoculars. You don't need a telescope to see them. So scan through the Milky Way and appreciate what these things are. Stellar nurseries, newborn stars, stars that have died and will create new stars. So it's all a wonderful, wonderful cycle going on up there. And when you see it with your own eyes, it's really, really marvelous. So I have enjoyed talking to you. I wish I could have done it in person at U-Bar-U, but next year, I'm sure things are going to be different. We'll all be gathered together again, enjoying each other's company and fellowship and marveling over what we saw in the sky last night. So thank you for your attention, and it's been marvelous. Thank you. Bye-bye.